that Deanna sent out. All right, so
I just hit recording, so we're now recording.
okay. And just so you know, there are resources for all this. You know, our work and our research lab really focuses on both individual systems thinking and mapping, and also systems leadership, which kind of takes you from, you know, the point of source information and structural thinking, systems thinking, to mental models, to individual learning, all the way through to organizational learning and up to vision. And the two resources there that we have are two books that we use as texts for our courses here at Cornell. And those are kind of broken into that individual systems thinking and mapping, and then organizational systems thinking. So before we get into systems mapping, just a quick idea of systems thinking. The complexity of complex adaptive systems emerges out of simple rules. And you've probably seen, well, that video is not playing, but you've probably seen the birds flocking. What we know about birds flocking is that that the emergent property of that superorganism of birds moving from, you know, in all kinds of ways, thousands or hundreds of thousands of birds operating as if they were a single superorganism, is actually based, we now understand, on very underlying simple rules that the agents follow locally. And so underlying complexity and adaptivity of these complex adaptive systems is actually underneath these simple rules. And what's important that I think our research really focuses on is that systems thinking itself is, in many ways, the ultimate complex adaptive system. If you think about thinking itself is very complex, and systems thinking is, by its nature, more complex than thinking. And the systems that we're thinking about are often very complex or CASs. And so systems thinking itself would have to be incredibly adaptive, and probably isn't some linear stepwise process. It's probably based on some underlying simple rules. And so we walk through these simple rules that mental models are viewed as a function of structural thinking and the information. That there's the distinction rule, which is that the distinctions are made up of identity other. There's the systems rule, which is that systems are made up of parts and wholes. There's the relationship rule, that all relationships have an action-reaction component. The perspective rule is that all perspectives are made up of points and views. And finally, rule 6 is simply that the structures, the DSRP structures and their elements, can interact dynamically with each other. So that's like an incredibly quick overview of what we call DSRP, and that's really underlying what I'm going to show you today, the systems mapping. DSRP underlies different types of thinking, so whether you're talking about emotional intelligence or systems thinking, pro-social thinking or scientific thinking, design thinking, creative thinking, critical thinking, that type of thing. Again, this is a pretty rough and quick intro just before we get into mapping. So when we talk about systems mapping, we're building it off of those elements that I just talked about, those DSRP and the corresponding elements, and that's really the infrastructure or the architecture of the software that I'm going to show you. One thing I would say is, if you want to solve a problem, first understand the system. And so getting into sort of solving real world problems, I'm just going to give you a few examples of maps so that you have a sense of some of the maps that what they look like. So here's an example of a refuge radicalization case that has a lot of different mapping in it. It gets kind of, you know, all over the place. There's a lot of different complexity to it. This represents about probably 800 pages worth of research on refugee radicalization and how radicalization happens in refugee camps. But then we can sort of, like any good baking show, we can take some of that complexity and reduce it and actually look down into it and see that that the research on refugee radicalization or de-radicalization actually comes down to 3 different ideas, and most importantly, that those 3 different ideas have to be connected by these relationships based on long-term financial planning and policy. And that becomes very important. That's what the research tells us about, that we have to take the policy attitude of the host government, the attitude of the local population, and the refugees themselves. It also talks a lot about 12 to 15-year-old kids, because those are the targets. I'll give you another quick example of some of how these things are being used. This is just a 2-minute video.
I want to tell you one last story. It's the story of the carnation evaporated milk. There's a factory in Modesto, California, right in the heart of the Central Valley, that is the only carnation evaporated milk factory in North America. Here's how the factory works. They make 2 million cans of milk a day. To do that, they take in 400,000 gallons of raw milk. Wait for it. Here's the complicated process for making evaporated milk. They evaporate half the water out, and they can what's left. That's it. That's the process. They call the evaporated water milk water. They also buy 88 million, or have been buying 88 million gallons of water a year, 250,000 gallons of fresh water a day to run the factory. So in one part of the factory, they're evaporating 200,000 gallons of water a day, the milk water, and throwing it in the sewer, and paying, of course, to throw it in the sewer. But another part of the factory, they're paying to buy 250,000 gallons of water a day to run the factory. They're also paying to throw that away. In the middle of the drought, a guy named Bob Valdez, who was the chief engineer at the carnation factory, said, "What in the world are we doing here?" That carnation plant has now, if it hasn't become a zero water factory at this moment, it will in the next few months. They are going to use the water that they have been evaporating off the milk and throwing away to run the factory. Why not? By the way, it's called milk water, but it's actually pretty clean at the moment it flashes up off the milk, right? It's evaporating. They are going to cut themselves off from the big pipe. In some places, that would be a financial disaster for the water utility. In Modesto, in the middle of the drought, the city and the community could not have been happier about this initiative. By the way, the people who work in that factory, they live in that town. They're not somewhere else. So that, to me, is obviously a brilliant example of smart water. Didn't require any, all it required was drawing the circle a little bigger.
So give you a few more examples of just the kinds of things that we're mapping with Plectica. And so here's a map that was done by one of my doctorals, or not doctoral, grad student, on the Flint water crisis. And in doing it, you know, her maps were very complex, and this is kind of the simplified version of a lot of complexity of analysis. But what she really zeroed in on is this relationship right here between the regulatory requirements and the safe water quality, that relationship that's seemingly meeting the requirements did not causally ensure safe drinking water. And that really is the crux of, and that relationship sort of didn't exist. That was a relationship that nobody sort of thought needed to be made. They thought that the regulatory requirements were the same thing, distinction-wise, as safe water quality, and yet they weren't. Safe water quality was not the same distinction as the regulatory requirements, but the assumption was made that those two things were the same, and therefore there was no relationship between them. But it was because of these things that the Flint water crisis occurred. There's a lot of other things that I could show you, but I'm just giving you some examples. I can show you some of these links. This is a case where Doug Dietz at GE, and you can read through this case. I can send it to you. It's a PDF. Actually completely changed the MRI and CAT scan machines that he designs as an engineer when he realized that they were just really upsetting the children. And so he started taking the child's perspective on the design and engineering of a CAT scan machine or an MRI machine, and came up with these whole worlds, which are now a whole separate product. And all of that was done through essentially mapping what the engineer sort of saw versus what the kid saw perspective-wise in the CAT scan experience or the MRI experience. So I can send you this as well as a case study among many other case studies. If you are interested, there's a number of them on the webpage. I'll send you this link as well, both case studies and white papers of the kind of problems that can be solved, whether it be for organizational learning and knowledge bases, or to design better services faster, or process flows, or this is Doug Dietz' example, et cetera. And then finally, just giving you kind of the flavor of some of what these maps can look like. This is another link, which I'm happy to send you, that just shows some of the different types of maps that you might see. And as you can see, that you can do a lot of different things. You can do kind of, basic things like World Cup and how that, or an empathy map for consumer purchases, or mind maps. There's, for the folks in this particular audience, there's causal maps and hierarchical maps, etc. So you can see a lot of different stakeholder analysis, SWOT analysis, soft systems methodology, hockey brackets, one of my favorite, March Madness, cycles of change, all different kinds of maps. So that it's not one particular kind of map, it's a lot of different types of maps in order to serve the particular problem that you're trying to study. And so I think that gives a little bit of an understanding of kind of understanding the system and mapping out the system. I will make one comment on why we map. I've never intended to be a visual mapper. I think we map because research tells us that the brain needs mapping. I don't think we map because it's like a thing that's inherently good or anything like that. I think we map because the brain is more hooked up to your hands and your eyes and your tongue than anything else. There's a thing called cortical homunculus, which is this big ugly guy up here. And that is actually a scientific study of the way the neurons are hooked up to the body. That's actually the way that your brain sees your body. If we asked your brain to look and give us an image of your body, that is the image that your brain would give it, based on the number of neuronal connections between it and the rest of the body. And there's an article here, which I'm happy to send you the link in Scientific American Mind, that we did on the research behind all that. And as a result, that's why we map. We map because the brain is tactile, the brain is visual, and if we could tie it to the tongue, we probably would do that too, but most people don't want to lick their screens. But if we were designing, for example, a map if we were designing systems thinking for dogs, we would make it olfactory and oral. So it would be ears and nose based. But we're designing most of the time for humans, so we make it tactile and we make it visual. And that's really why. And then the other thing I think that's important is that we're fundamentally social animals, and we think socially. And so making things collaborative online is obviously a really powerful way to do that, especially when people are apart. But being able to map collaboratively and interact with people's maps collaboratively is critically important. So I'll show you a few of the collaborative features, and I'll just walk you through a number of them here with a new map. So I'm going to go over here and create a new map. And I'm going to take this link and I'm going to send it to my daughter so that you can see this. I'll also just put it in the text, and if you are logged into Plectica, you can get into that same map as well. And you can see that in this map, I can create cards, and then I can label these cards, you know, I always seem to pick dog or cat and deer or something like that, whatever. And now all of a sudden you can see Alina, my daughter, she's come in and she's created a card called fish. And you can see her cursor, and now she's created that relationship. I can see what she's doing. She can see what I'm doing. I'm making a card there, and I'm making a relationship there. I can also see her up here, and if there was 10 people or 50 people, sometimes we get hundreds of people on the same map. I can see, by hovering over Alina, I can see the things she created versus the things that I created versus somebody else. It looks like these folks haven't created anything. But you're welcome to click and create things, and you can see how that would look. It looks like 2 of you have joined here. Does that make some sense? So that's kind of the collaborative, being able to share maps. I just did that by sharing a link. You can also, in part, being collaborative means using things that other people have invented, so that you can start maps with a template. So for example, if you wanted to do a business model canvas, or let's say you wanted to do a mind map, you can simply start by using the mind map template. And that's a form of social learning, because somebody obviously, Tony Bazan actually created, the concepts of mind maps, which are centralized or stuff like that. And so we can start there. Or somebody could send me a map, and I can simply make a copy of it. I can either work with them on their map, or I can duplicate the map and simply make my own copy of it and then do whatever I want to it. So that's another form of sharing. You can share in a number of ways. You can invite people. If you know the people that are on the system, you can invite them. So I can type in, again, my daughter, and I can invite her to this map. You can get a shareable link, which is either a view only or an edit link, and just share that like I did in the text there. So if I shared the view only link, that would share that with you, and you can see that when you click on it, there'll be a thing up here that says view only. But if I share the edit link, then that allows you to edit. I can also share presentations, which I'll show you more about presentations later, and I can actually embed the map in websites and other things. Another thing that's important to understand is that this can happen synchronously or asynchronously. Right now you can see Alina in there making some changes or moving around. That's synchronous collaboration, but obviously she could be doing that at 3 in the morning, and I could have sent it at 9 in the morning or whatever. And so that collaboration can happen out of sync or in sync. You can also comment on maps. So going back to, go back to my other map there with Alina, with the dogs and stuff. So I can go over, and let's say Alina said fish, cat eats fish and fish is scared of. I could click here and I could say, what if it's a shark, or something like that. Have you considered that, or something like that? I can comment, and we can have a whole thread on just that card, or I can comment on a group of cards. I can comment simply on the canvas itself by simply right-clicking and making a comment, like that, something like that. Or I can comment on a whole group of cards by, let's see, where's comment? Add a comment, need more here, or something like that. And you can also see the comments, so you can see them up here in the upper right-hand corner, so you can see the different comments, and those are all threaded comments. So Alina can write back to me, depends on your perspective, right? So then we would need the perspective feature, which I'll show you in a sec. But so the comments can be threaded by the card. There, she just put in a picture of a fish. So that clarifies that we're not talking about sharks, but goldfish. that type of thing. There's also the perspective feature. So I could sort of say, well, my perspective is this, that, I'm looking at this and this and this, and Alina could put her perspective in over here, and she could see different things. And so she could literally sort of change the perspective. So when we look at this, we see the things that are in my perspective versus the things that are not in my perspective. And I'll show you a little bit more about perspective later, but collaboration-wise, perspective is a form of collaboration. You can also see recent activity, so that allows you to see what everybody's done. That's really helpful in collaborating maps because you can, if you come back to a map that you've already created, you can kind of see what's happened since you last looked at it and stuff like that. And you can actually play back, so you can play kind of almost like a videotape of how the map evolved, essentially, over time. And that's really helpful in educational settings where you can actually see your students thinking, because you can see how it started and then how it changed over time. That's about it. You can export the map, again, all in the sharing function. You can export the map as an image, PDF, PowerPoint, or JSON. So if you wanted to, for example, share or collaborate inside of PowerPoint or something else, you can export maps and things like that. And then you can also do waypoint presentation. Waypoints are very important. And what that allows you to do is have like a linear presentation through a nonlinear map. And I'm going to show you a few of those in a bit. And finally,
Derek,
yeah.
Before you go there, when you showed the development of the map, how does that go back to the beginning, or the changes for this session, or?
That's a great question. So in order to avoid some privacy issues, it goes back to when it was shared. So when I look at this map, it'll go back to the very beginning. But if I create a map and then I share it with you, then you'll see any changes that happened after the sharing.
Okay. Thank you.
Right? And then finally, over on the map kind of view, all your maps. This is kind of like your platform. These are the ones created by me. This is kind of like Google Docs, example maps, shared maps created by me, and maps, create a new map. You can also create a team. So you can create a workspace where you can invite people to that workspace, and any maps that are in that workspace, those people will have access to. So that just saves you time in terms of if you have a team that's working on a project with certain maps, you can create a team or a workspace very simply by clicking the workspace button and have a collaborative feature there.
So Derek, Steve Wallace had a question. Can you export a map as a spreadsheet?
You cannot export a map as a spreadsheet, but you can cut and paste from spreadsheets to maps, from docs to maps, from the internet to maps, and things like that. So if I take a spreadsheet or I take a Word document and I cut what's in it, it will take the things that are in the cells and create cards for you just by pressing paste into the canvas. And if it's a bulleted list, for example, in a doc, it'll create a part-whole system, for example. Like if it's A and then A1, A2, A3, it'll create a part-whole system with 3 parts, A1, A2, and A3.
Okay.
Okay, so those are kind of like the top 10 sharing features for working together. That's a really important sort of understanding of Plectica, is that it's made to not just to think systemically, but to think systemically together. The other thing I would say is when we look at DSRP and we look at sort of what DSRP tells us is possible, there's kind of those simple rules might seem really basic and really simple, but the way simple rules work is they interact together and they can create massively complex and emergent properties. These are just a tiny sampling of some of those things, but what we've noticed is that there are three things that people tend to do. They tend to identify cards or something. They identify things. They say dog, they say cat, they say fish, you know, they make identities. They tend to occasionally list down into those things the parts of things. So they're pretty good at part whole, or one dimension of part whole. And they will occasionally see relationships between things. Left to their own devices based on a normative K-12 experience, most people will do those three things on the left. But there are 10 things that we see that people need to do more of. And I'm just going to give you a few examples of what we mean by that. So othering is just, distinctions are made up of identity other. So we can start a distinction just by simply saying there's an identity. And maybe we don't even know what the name of the thing is yet. We just know that there's something that is sometimes a wolf, not a cat or a cup. It's an animal, and it's sometimes a pet. And then, you know, that happens pretty quickly for us if we're an adult and we think dog. But if you're a kid, you know, you might have to think through it, and you'd end up with dog. But we can distinguish further. So we can say not just the label dog, but some of the summary text for dog. We can add images to distinguish. We can add videos. We can add files and things like that. Any kind of file can be drugged into the card. And we can also use attributes to define some of the things it is as an attribute, like it is a wolf, but it's also not a wolf. It is furry, but there's also not furry dogs. It's not domesticated, and it is domesticated, those types of things. So we're just dealing with identity other. That's one example, just in something simple like dog. So every word in the English language is sort of has that level of complexity to it. But we also might think in terms of something like this, where we have a relational set of identities, like some mental model that is dealing with humans in a corporate setting, but is not really managing them as resources. So you have kind of the distinction human resources, where humans are seen as resources. But then you might distinguish that from talent management, where humans are seen as talent to be managed. And you might even distinguish that from talent development, where humans are seen as talent to be developed. But you might criticize that and say, well, really, we don't want to develop them like we do in developmental psychology or sociology. We want to actually just engage the talent. So humans are seen as talent to be engaged. And it just depends which distinction you want. If you're starting a new thing and you're creating a new department, calling that department human resources probably is going to influence the way people think about what the function of that department is. And so if you called it something different, the distinctions really matter. I'll give you an example that the superintendent of West Point gave a speech, and his culminating speech of his experience at West Point was simply to compare and contrast the distinctions of West Point Military Academy versus other colleges and universities. And what he said was, we are at West Point a military academy, not a university. We exist on a military base, not a college campus. We have barracks, not dorms. We have tactical officers, not residential advisors. And we have cadets, not students. And that's what he was worried about, was that the military academy was becoming too much like a modern university. And so those might seem like very simple words. There's nothing terribly complex about it, yet it was the culminating sort of thoughts that the superintendent of one of the great universities or military academies in the world thought was critically important. So these kinds of distinctions are very important. Going back, parties, I want to show you just a few, and some of these other ones that we're talking about. If imagine, this is a relatively simple map, but all of these things that I'm talking about apply across the most complex maps. Imagine, for example, that you have three things, and this is in presentation mode. So I'm going to walk you through just by clicking down here, the presentation mode. And those three things are related in some way. Now you could zoom in and see a list of parts of that thing one, and then look over at the relationship to thing two. And then thing two is what's called a freehand container, which is a little bit different than a list because it allows you to create a complex system that has complex relationships and complex structure that's not just list form underneath. And that's called a freehand container. So the system that's inside the box can be as complex as the system that's outside the box. And we can even zoom into that relationship because D, S, R, and P interact with each other. We know that the R's, the relationships between things, can also be distinguished, and they themselves can also be whole systems. And those systems could even include perspectives. So what we're looking at here is a single relationship between this part and this part that is made up of a complex system, or a feedback loop in this case, that's being looked at from 3 perspectives. And that's the relationship between this part and this part. And this is called a pop-out, which allows you to have this relationship in place, but still see the infinite levels of complexity that are part of that relationship. When I mean by infinite levels of complexity, I saw a wince there. I don't mean that this map right here is infinitely complex, but it could be. In other words, there's no limit to what you could put inside that box. You could create any level of complexity that a map could be inside of that box, which is that relationship between those 2 objects. So
Derek,
itself is not complex. It could be as complex as you want it to be.
So Derek, on the right-hand side of this, where it shows part 1 related to part, in that circle, those individual parts could be broken down further if it was appropriate. Absolutely.
That's sort of that's the power of DSRP, is that there's really no, let me get back to that where we were there. There's really no limit to what you can do. I can take those parts and if I click, right now it's in presentation mode, but if I want to click this open and I want to add a part, I can add a part to that. And I can add as many parts to that, and this whole map of complexity could be inside of that part right there, with perspectives and all kinds of other things. So that's what I mean by D, S, R, and P themselves are very simple, but when they combine with each other, there is literally no end to the fractal complexity that you can have in your thinking. Okay, so I'm going to go back to this is kind of a pop-out and a freehand container, and you can see what's going on there. Then in thing 3, you can lay it out differently with relationships across systems in between parts. And then you go back to the thing 1. Now, this is very important, and we've seen this again and again in our research. One of the most important things that the human mind needs, which computers don't, is compression. That's also maybe something that you've heard of in terms of chunking by Herbert Simon. The human mind, if you give the human mind a network with thousands of nodes in it, it might think, wow, that's a pretty picture, but it is not going to glean a terrible amount of meaning from that network of thousands and thousands of nodes. A computer can sift through that network very quickly, but the human mind cannot make a lot of meaning out of that, other than that it's a pretty picture. What the human mind can do is make meaning when there is chunking involved, and chunking causes compression. So what you can see here is that there's some level of complexity in the whole, but we can compress. I opened this earlier, so it's going to stay open. We can see the complexity of the whole, but then we can compress it. And the human mind can say, oh, these are 3 things related. I get it. Whereas that's a lot of information, but I can still get it because it's 3 things with stuff underneath, with stuff underneath, with stuff underneath. Does that make some sense? So what we've seen over and over again is the difference between really, really good understanding of systems and not so great is this idea that there is compression, that we can understand the detailed, we can zoom into the molecular structure of a leaf, but then we can zoom out and see the forest and know that that molecular structure is in that leaf, but not necessarily have to occupy our brain with all the molecular structure of the leaf while we're looking at the forest.
So Derek, I think Steve Wallace might have a follow-on question.
Yeah. Might identify similarities across.
Unmute. There we go. There we go. Yeah. Yeah, I'm thinking of that in terms of drilling down, but there's also a similarity there with the idea of abstraction, but I think you're talking about differing levels that you're looking at. And I'm wondering if you have a potentially nearly infinite map that might be tremendously confusing. So does Plectica have a search function that we could use, you know, having created this magnificent map, perhaps by people all over the world collaborating? Is there a search function? So if I decide I want to look at leaf structure, I could search through an existing map and see that, yes, there's leaf structure and it's related to molecular structure and so on.
Yes, so it has a search function. If you just press Command or Control F on your keyboard and then type up here, you can see I'm typing the word part because I know the word part appears in this map. And as I type the word part, it will light up all the places where part is. And it'll tell you how many there are. So there's 26 of them. It also has a search function in the map in your like your main window here, where you can search for anything, and it'll not only search the titles, but it'll search inside maps and tell you whether that word is in the title. You can see that's in the title, but this is telling you this is in the content of the map. Great question. Okay, so there's the compression, and I think that's it on this map. I mean, what this is really getting at is showing that you can take a nonlinear map and you can help people walk through it in a linear way using, in this case, the waypoints presentation mode. You can start the presentation. Now you can send people a link to your presentation, which is just the presentation. So all of the sort of complexity is missing in the map, and all they have to do is click forward or back, and you can walk them through the presentation of your nonlinear thinking in a linear way, which is critically important because, you know, at the end of the day, communication is happening in time, so it tends to be stretched linearly, even if you're talking about something nonlinear. Okay, so that kind of hit on a number of these different things: pop-outs, freehands, parties, seeing relationships, not just seeing relationships, but distinguishing them, and not just distinguishing them, but turning them into systems themselves. Compression, we talked about waypoints, and also, as system dynamics does so well, creating or looking for systems of relationships rather than just systems of things, which is incredibly important. This is just a very short list. DSRP, as a set of simple rules, actually elucidates thousands of these things, but I'm not going to go into those.
Derek, could you say more about recognizing patterns of relationships, using the map to do that?
Yeah, so as a simple example, this map right here is sort of using, in this case, it's using, let me go back to this slide here, it's using color and shape and thickness to sort of say that these three relationships are also a part-whole system. And so in systems, we have relationships, but then we have relationships that are actually working in cahoots with each other to cause to be a system themselves. So the relationships are part of a larger system of relationships.
Okay.
And that's combining S and R into, you know, so that's a combination of the S rule and the R rule.
Thank you.
Yep.
Hey, Derek, good stuff. Going back to the introduction, we were talking about the condensed milk factory and the example of the there's another example of oh yes, the regulatory issues being lost, so to speak, in Flint. Those, I think, are two excellent examples of what systems thinking can really contribute to the world. And I think of that in terms of being able to identify what's missing to be able to look at a system, whether it's usually from a mapping perspective, but being able to see that there is something missing on the map. And I'm wondering if you could speak to how some or all of the parts of DSRP, parts of DSRP, but anyway, dimensions of DSRP perhaps help people to see what's missing.
Yeah, that's a really important part of what DSRP does. In fact, I'll come back to this so I can just answer your question with something that I was going to cover since you're asking it now. Let me show you the difference between describing and predicting your thinking. And we talk about this a lot. We talk about descriptive systems thinking versus predictive systems thinking, or predictive analytics. So I'm just going to give you a simple example here. This is a very simple map. And you know, lots of maps can be descriptive, meaning you know something about your system and you create a map that describes it. But what about if you're trying to be predictive? In other words, you're trying to figure out exactly what you just said, Steve, is like, what am I missing? What have I not thought of? What DSRP really powerfully does is tell you what you haven't thought of, and also in relation to what's possible. And it's a very pragmatic thing that I'm going to show you in a second, but there are also mathematical estimates to what is possible versus what you've already gotten. So for example, let's say you're doing something like program evaluation and you're thinking, I've got a program and I've got an outcome, and obviously they're related because the program brings about the outcome. Now you might sort of then say, okay, let's say it's a program is rock climbing and the outcome is some kind of mastery, right? So you might fill in this abstract logic model with something more like this to be specific to the program. Make sense so far? Now, what DSRP does is things like this. It says to you, okay, you made a relationship between rock climbing and mastery, but what is the distinction of that relationship? In other words, turn the relationship into a relationship distinction. So you're just asking a question, and DSRP is telling you that that's there. It's telling you that that likely exists, and you can decide whether or not you fill it in. So what might you fill it in with? You might fill it in with rock climbing evidence leading to mastery. And then that might be filled in with what are the parts of evidence, and that could lead to a whole system of how we understand evidence. And this is a model that we teach at Cornell around the condition of knowledge and methods choice in order to develop evidence of either causation or correlation. And that's really what you're fundamentally doing or not doing in a logic model that so few people do. So we're filling in that relationship. But we can go further with DSRP, because we could say, for example, okay, we've got that part, but what are the parts of rock climbing? And what are the parts of mastery? And we might fill those in now that we've asked the question structurally. In other words, we're predicting that structurally those things will exist, and then we see that they do. So for example, we might see that in a program of rock climbing, we not only have the climbing part, but we have the belaying part, and we have the observing part. And each of those three things, let's say for your students in your program, would have perhaps are different activities and are different outcomes. And so we might think about, well, what are some of the outcomes and things like that. And then we might say to ourselves, okay, well, if we have these things over here and these things over here, anything can be related. What are the relationships and how are those distinguished? And all of this is just through structural thinking, right? And the map is building as a result of this structural thinking. And then we might say, okay, we've figured out what all those relationships are and what all the mastery of rock climbing versus mastery of belaying versus mastery of metacognition and observation. But what does it look like from different perspectives? In other words, this whole thing could change if we look at a student perspective or a guide perspective or a programmatic perspective or a funder's perspective or a researcher's perspective, et cetera, or a parent's perspective, et cetera. And so we might change our map based on that. So those are very simple. All the places where there are question marks, we're essentially using structural predictions to say there is something structural that probabilistically is there, and you need to decide whether or not it needs to be filled in or not. And there are examples of this in mathematical terms where if I give you three things, we know, for example, that the equation is n to the n minus 1 or n1 divided by or not divided by 2 that give us, for example, the number of relationships between things, right? And so on and so on. There, I can give you mathematical formulas for each of the patterns that tell you how much will be there, mathematically speaking, etc. So if you told me I have 22 things in my map, there are 22 times 21, either divided by 2 if you want to get into the elements, or not divided by 2 relationships between those things. Now, what's interesting about how DSRP works is as soon as you create those relationships, now you have 22 times 21 plus 22, you now have more stuff, and all those things can then be related. So that there's an exponential curve of possibilities. But all that can be calculated.
Yeah, and there can be. What I like there is that as soon as you have 2 or 3 boxes, it says, oh, how many connections might be there, and that leads you back to the question, is there evidence to support those, which then leads you to other things. So it seems like each of the dimensions of DSRP can feed back into the other, leading the person into a sort of exploratory path to improve their knowledge and understanding. So I'm liking it.
Right.
Good stuff there. Thank you.
We're working with NSF. That's absolutely right. We're working with NSF right now on an educational aspect to this Plectica mapping, where when a student puts down, in order to try to develop their systems thinking abilities, when they put down, let's say they put down 3 things, the software will actually use some machine learning and some artificial intelligence or something like that to sort of say, hey, have you thought about these relationships? Is this a salient relationship? Is this a salient relationship? And so that's really building those neurons or burning those neurons to get kids thinking, about relationships or about part-whole systems or about the distinctions they're making, or to take perspectives at an early age and get into the habit of doing it. But it's very micro because it's happening as they're mapping. It's not like pedagogically enforced. It's just a micro thing that's happening as they're mapping.
It makes me think that this enables theory building.
Yes.
That as Steve was saying, you see the number of relationships there. Some of those you have evidence for causality, and you can plug that in. It seems like you could also weight the probability that a particular relationship has any meaning or not, so that you go, really feels like there's evidence that supports a stronger relationship between these 2 items. And there could be these other possible relationships, but there's not much evidence, or it seems like there would be a weak causality. Can you show strength of relationship, visually?
Visually, you can show it by just adding a distinction. What we don't do yet is, although it's certainly entirely possible, but we don't do it yet, is actually being able to calculate the cards, right? So we can't create equations per se yet, but you can add anything. You could say this is a 0.5 and this one is a 0.3, or that type of thing to any relationship. And you can also do all the things that you would imagine you can do, like you can make these elbows, right? You can make them curvy. You can make them colored. You can make them dotted. You can make them thick. You can make them have arrows or not have arrows, or have arrows both ways, and all that kind of stuff. And of course, you can make the cards, same thing with the cards. You can make the cards, different colors, etc. You can make the cards any size you want. You can just drag the card and make it big. You can drag any card can become a part of another card just by dragging it in or dragging it out. So everything is very tactile and visual. If I decide, oh, this thing that I made over here is actually part of that thing, I can just drag it in there and it becomes part of that thing. And if I want that thing to have a subsequent part underneath it, I just click and make another part. And then if I change my mind, I just drag it out and it's out.
Derek, I wanted to ask a question way back when you did the carnation milk thing.
Yeah.
So the question is about where is the sweet spot for Plectica? Because if you were looking, you don't need complex mapping to have realized that there should be a relationship between water waste and water usage in that situation. And even in the Flint, Michigan thing, bringing in stakeholders and asking, I mean, basically design thinking, where you're bringing in stakeholders and saying, are we serving this need with the regulations for clean water? It's not clear that there aren't other ways to achieve the kinds of things that we can see with complex system mapping. So where's the sweet spot for this tool, do you think?
In terms of, I'm not sure I understand what you're getting at.
Well, you don't need this tool to solve the evaporated milk problem, right? There's a lot of other ways of thinking about it that could have got you there.
Yeah, I mean, you don't need this tool for anything. I mean, DSRP is you're doing DSRP whether you like it or not. Whether or not you want to use a tool that helps you do it visually is whether you choose to use the tool. But either way, your brain is doing DSRP. You can't think without making distinctions. You can't think without making relationships. We nest things inside of each other and we take perspectives. Just cognitively, that's what we do. Right.
Well, so where do you feel the sweet spot is for this tool, the level of complexity, the type of problems where this tool helps you do things that are more difficult to do without it?
Yeah, I think that if I understand your question, it's a great question. I mean, strict network analysis is very powerful, but you need a computer to read it if it gets really big. So I think of this tool as being like essentially a human-powered and computer-supported analysis and complexity tool, right? But it's inevitably about what humans can think and what humans can do. It's not about how much data I can crank into something and then like have my computer spit out an answer without any insight or creativity or that type of thing, right? A computer can kind of crunch the numbers, but it's kind of like it's only as good as the data that you put into it. What's amazing about the human mind is we can think things that weren't really part of the data that we put into it. And the reason we can think those things is because we're thinking in these structural predictions that allow us to take these quantum leaps and see things in new ways by seeing different perspectives and things like that. I don't know if that answers your question.
Fair enough. It was a messy question.
Yeah.
And Derek, I had something along the same line, but I'm thinking that the tool could be beneficial to those people who don't think in systems, and having the different perspectives. And I would think that's where it could come. I mean, probably everybody on this call sees systems everywhere we go all day long, but that's not true for everyone.
That is super not true for everyone. That's sort of what this slide, I mean, what we've seen over and over again in our research is this is pretty much what people do all day long, these three things over here. And sometimes they don't even do two of them. And so like we don't want to be in a situation where the leading people in the field of systems thinking are thinking in all these complex ways, and we're not bringing the rest of society along and helping to people to see more relationships and take more perspectives. And so I think that at the same time that we're pushing the envelope on the cutting edge of systems thinking, which DSRP does, we also have to be pushing the envelope on the entry edge of systems thinking, which DSRP does. That's why we can teach it to the top level people in the world studying the hardest things, and we can teach it to kindergartners.
Mm-hmm. Yep.
I think
that's
really
awesome. That's awesome. Very good stuff. Backing up just a little bit to Jim's excellent question, where we find, or we've kind of placed mapping work is with small to medium-sized organizations who can't afford the big computing power and the unbelievably expensive and complex process of the computer analysis and that sort of thing. I'm starting to build that into the papers that I'm writing, but also the process of building a model collaboratively engenders a lot of trust between the participants and trust in the model.
Mm-hmm.
Whereas if the expert comes in and throws a huge model at you, says, you need to do this. And the participants and stakeholders just scratch their heads and walk out of the room because they have no.
Mm-hmm.
So building on that is another follow-on question, Derek. If you have, let's say you have a nonprofit agency that's scattered all over the country, and stakeholders, members of that organization, are jumping onto Plectica to collaboratively design a knowledge map for what's going on, process theory or something like that. And they are committed to creating a map that's based on DSRP principles. Is it possible for them to misuse it? Is it possible for them to start mapping and then, say, some people start tossing stuff onto the map that doesn't connect with other things or that are on the map, or adds to the confusion? What are the pluses and minuses of that sort of process as it might be addressed now, and how might we work around that so that the ultimate map is that's collaboratively developed can be better trusted by all the people who have been developing it, if that makes sense?
Yeah, I think it does. I mean, I guess I'm not sure I would go so far as to say that they can misuse it. I certainly think that they can underuse it. But we can think stuff, and DSRP is just sort of giving you a language for what's happening when we're thinking stuff.
Mm-hmm.
And I don't know if you can misuse thinking, but you can certainly underuse it. What I think the mapping does, along the lines of what you're saying, is if you have multiple people on the map and you have a bunch of stuff over here and you have a bunch of stuff over on the left there, and you sort of visually are forced, if you have any understanding of DSRP, you're sort of visually forced to think of it like this, like you've got a thing over here and you've got a thing over here, and maybe you should think about, are they related? Are those two things related? And how are they related? And we see this all the time with executives and enterprise, is that they don't think that. They've got a system over here and they've got a system over here, and nobody ever thinks, well, what's the relationship between those two things? And that's why we have silence, right, in organizations. So I think it can help in sort of making the obvious more obvious, or the less obvious more obvious. The other thing I would say is, as collaborators, if your expertise lies 3 levels deep in this thing right here, well, that can be an entire map with the whole complexity of your expertise, and that can be your zone that you work on, and yet your work is being contextualized by the work and expertises of others. And so you can really get a lot of different experts on, or a lot of different people from a lot of different places, like your nonprofit, and they can be mapping where their domain expertise is. And then that map can kind of build together with all the different expertises, and then it can be compressed into something that's understandable by everybody, but also contextual for everybody.
Yeah, very good, very good. And what I'm seeing also is that if something is built into the map, for example, somebody draws a connecting arrow, or preferably, hopefully, causal arrow between 2 boxes, when the question mark pops up, that sort of presents a question to the group as a whole, saying, where's the evidence to support this? and then they can weigh in through the conversational part of it, and perhaps even, sorry, thinking out loud here, if one person creates an arrow, it might pop up in a red color saying that this is just a personal opinion. And then as more evidence is added, the color of the arrow might change, or the size of the arrow might change, indicating that it's a more supported arrow, and therefore more trustworthy, and therefore building trust in the map and in the collaborative process. So yeah, so I see some good, interesting applications there.
Yeah, the only clarification I would make is that the relationship lines are not always causal in a DSRP map. They're only causal if you make them causal. So, for example, you could have, you know, husband and wife, and the relationship could be, you know, marriage. And that's obviously not a causal relationship. It's just a relationship between them, and you could make the decision to either
Actually,
not have arrows at all.
Actually, it is causal. They're only husband and wife if they are married.
Sure, you could think of it that way, but I'm just saying not everything, not all of the relationships. I think you're right. I mean, you could think of it as causal, but not all the relationships in a DSRP map are necessarily, they could just be conceptual relationships. They don't have to be causal unless you decide that your thinking is that they should be causal.
Derek, could you say more about perspectives? That seems really interesting to me, to look at the same system, but really pay attention to the perspectives and how each perspective may see that system differently.
Yeah, let me try to find a, let's see, perspective.
So that's one of the things that happens in those silos, is that people come in with very different priorities and energies and information. They see the system differently. And to be able to look at that together as a collective, say, this is the way I see that system, this is the way you see that system, is a huge step in terms of collectively aligning and respecting other people's views.
Exactly. And so one way that perspective works is you can literally sort of, this is just a simple example, but you can literally sort of see that this is a point, this is a view. And if we click on the optimist perspective, it tells you that it's half full. And if we click on the pessimist perspective, it tells you that it's half empty. And so we can actually look at the same thing and see something different from a different point of view. There's also the function of perspectives is that, let me show you, let's see, I think this over here had some perspectives in it. Oh, this is a perspective. No, let me find a good perspective map. I think that maybe this is a good one. Just to give you an example, you know, you can see, for example, the things that light up from the Civil War according to the Northerner perspective. These are the things that light up as causes. And if we shift to the Southerner perspective, these are the things that light up as causes. And so the Southerner perspective on the Civil War is a lot more complex, not necessarily in a good way, just more robust, more complex than the Northerner perspective of the Civil War. And even the name that they call the thing is totally different. The South calls it the War of Northern Aggression. The North calls it the Civil War. Generally speaking, we would call it the North American War, occurring between April 12th and May 9th, in order to get away from that bias of what it's called, right? So these two perspectives are not only changing the distinction that's used, but changing the parts and the relationships that are seen in the system. And those perspectives can be people perspectives, they can be things, they could be animals, they could be, you know, person, place, or thing, but they could also just be concepts. Any card can be a perspective on any other card.
That's so interesting, that example. From a Wallace perspective, I think Steve would probably say, since the Southern view has much more complexity, it's a more mature view of the space from a theoretical space, and that the northern perspective is somehow shed a bunch of the complexity and therefore has lesser understanding.
Perhaps, yeah.
But we see that sort of relationship when people have, so we say, scientific thinking and deeper expert knowledge. They see more pieces and more connections, whereas more emotional thinking is, we see like one idea and it's surrounded by a fuzzy cloud of assumptions that protects their idea from any kind of challenge.
Yeah.
So Derek, this leads me to wonder. I think Plectica is an awesome and continually improving platform. And now I'm starting to think, what about a 3D version where you could sort of fly through the space and perhaps rotate those perspectives? Because, for example, using the North-South War as an example, one person might see one concept, for example, I don't know, one card as the most overpowering, awesomely, totally negating everything else most important thing. So they might see the same map might be there from a top eye perspective, but from their perspective, the whole map is rotated. So all they see is that one most important concept, and maybe peeking out from the edges some other concepts, but they don't see the complex and interconnectedness of the whole picture. Whereas somebody else, if you were to rotate that view from their perspective, they might see some parts of it, but the parts that they see also obscure some other parts of it. Yeah. Or that one big thing might be seen in the far distance as a very small and insignificant part of the picture.
Yeah.
Any possibility of 3D rotation coming up in Plectica in the future?
I would say there's a possibility, but it's it is fraught with problems. It's fraught with problems, and one of the biggest problems is 3D just giving you kind of a whiz bang effect that feels like it's cool and feels like it's telling you something, or is it actually increasing the meaning? And I think if you look at a lot of the 3D, a lot of the research that's been done by Edward Tufte at Yale on visualization really looks at, like, a lot of what we're doing in 3D is not actually increasing our understanding of what we're looking at. And so the reason I say it's fraught with difficulty is because it's easy to do 3D, but it's hard to do 3D in a way that actually increases human understanding in a significant way without also hampering it. And so I guess I would say I would love to go in that direction. We've explored much in that direction, but we are cautious about doing it in a way that's really meaningfully different and not just sort of what Tufte calls chart junk, right? If I take a two-dimensional pie chart, for example, and I show that to you, the mind can kind of pick up what that is, or a bar graph. Now, if I make those bars three-dimensional, that actually does absolutely nothing for you, other than that you might be like, oh, that's really cool. But your brain isn't actually taking in really any more information, knowing anything more as a result of that 3Dification. And so we want to be really careful of that.
I'm wondering, though, if that 3D was a little bit of a red herring, because I think Steve was going after the same thing I was, which was when you look at something from a different perspective, whether you render it in 2D or not, you could change the weight of the relationships, yes, and the strength of the concepts, and maybe even the directions of the relationships.
Yes.
Is there a way to, I mean, that would be so powerful to be able to flip back and forth.
That's precisely the direction that we're heading in, is things like that. That
highlighting helps.
Yes, absolutely.
But it could be a lot more in terms of emphasis and importance.
Yeah, sorry, Steve, if I took the 3D too far. If what you meant is more what Jim's saying, yes, we're completely interested in that kind of thing, where you can really compare and contrast perspectives by weighting or by coloring or by size differentiation and things like that. Whether or not 3D plays into that, who knows? But absolutely, what is totally critical is to be able to compare and contrast and distinguish between different peoples or different perspectives, so that you can really see the difference between them and see, like, when I shift over here, you know, my parts change, my relationships change, my distinctions change, everything changes.
So would you be able to then have a single map and say, for example, click on, you know, person A's perspective or stakeholder group A perspective, and certain parts of the map would light up. Then you click on stakeholder group 2 and different parts of the map light up?
Yeah, we can do that already. I'm for some reason drawing a blank on a great map to show you, but I have thousands of them.
Well, while you find that, I'm just going to remind people, we've got about 14 minutes left. So if you have a burning question, be sure and put it in the chat, because I don't want to leave you out. And
I've already talked too much, so I'm going to shut up.
Yeah, I'm trying to, like, give other people space. But Steve, your questions, as always, are great. So no problem. But I just want to make sure.
I'll stand down.
No, nobody stands down. But if anybody has a burning question, just stick it in the chat so we don't miss anything.
I'll have to send you a map of what you just described, Steve. We have tons of maps that do that already, where you can look at something like the Doug Dietz example. We look at the whole design and engineering of an MRI machine based on the kid's perspective versus the practitioner's perspective versus the engineer's perspective.
That's great.
You know, and you just see completely different things as a result. Like, the kid doesn't see anything of what the engineer sees. The kid sees this really frightening machine that's got these, like, glaringly scary things on it, and they're, like, terrified and they're crying. And the engineer's like, oh, this is a sleek, beautiful, you know, Apple-looking machine. And the kid's, like, you know, freaking out that they're gonna die if they get in this machine, because it's like a gurney. So I can send you some of those maps. I did want to just hit on how Plectica is the same or different than other softwares or other things that you might use out there. I'll start with the sort of most basic things and the things that are used probably the most: an Excel spreadsheet. I mean, obviously, you can DSRP in an Excel spreadsheet. If you look at this thing here, you're kind of got authors and country and discipline over here. These are like perspectives, and they change based on the case. So you've got a lot of distinctions. You can relate things in an Excel spreadsheet, but the relationships are often not obvious or not visual. You can't see them. They're in the equations or something like that. If you look at Google Draw or Visio, all of those types of things, again, they're doing part whole. They're doing relationships. If you look at this type of thing that we see a lot, graphs, you have a system of distinctions over here related to a system of distinctions over here, and there's relationships going across the graph. Mind maps are highlighting really just part whole structure, believe it or not. This is something that confuses people a lot when they look at a mind map. They think it's a very relational map because of the way it's drawn, but actually a mind map is almost entirely a part whole nested structure with almost no relationships whatsoever other than the part whole structure. If you look at any of the different network softwares, which there are many of, Kumu, Python, all kinds of things like that, what you're seeing is you've got mostly relationships and identities, but you don't have part whole, you don't have perspective, you're not questioning the identity. And by the way, most of those maps, the relationships are homogeneous, which in your thinking, your relationships are not homogeneous, like this Python map here. All of those relationships are one single type of relationship. If you're thinking in lots of different types of relationships. So that makes it difficult in Python and Kumu and things like that. And of course, in like things like system dynamics, again, you have distinctions that you're making, you have relationships, you have systems of relationships. You don't really have your part whole nestedness. It's a flat map like all these maps are that I'm showing you. So you have almost no nestedness and you have no perspective. and you're not questioning the identities that you're making. So DSRP is really just trying to help us do more with whatever it is that you're using. It doesn't really matter what you use. It more matters what your thinking is while you're using it. And if you do a search, for example, in Google image search for diagrams, look at everything in there. Every single image in there is using D, S, R, and P to one extent or another, sometimes failing in some regards and succeeding in others, and sometimes, almost very rarely, succeeding in all regards. But every image you do, and I've been doing this for a long time with students, challenging them to find an image that doesn't. I haven't found one yet, so. And we kind of talked about describing your thinking versus predicting it. Just quickly, in the last few seconds, I guess, so that we have things called sliders and jigs. Sliders are really things that are dealing with cognitive behavioral therapy, self-help, all those kinds of things. This one is a slider, what's called a slider on thinkings and feelings, and how to differentiate thinkings and feelings, which actually turns out to be a very difficult thing for humans. Sometimes it gets conflated. What they're thinking and what they're feeling gets conflated. And we have many, many sliders that really get at the social and emotional intelligence. So these are all slider maps of different kinds of concepts that I can share with you to show that we can deal with not just the analytical domain, but the emotional and social domain, as well as the motivational domain. So that's, I think, really critically important, that we don't just end up being highlighting just analytical skills, that analytics, cognition, fundamentally, the way the mind works is that it's made up of cognition, it's made up of emotion, and it's made up of motivation or cognition. And those three things really have to be together in the human mind in order to, live a life and stuff like that. So we also have things that we call jigs, and jigs are super important. There's a whole chapter on jigs in our book, and this is a map of jigs that I can send you, and you can walk through and learn more about jigs. But a jig is essentially what it sounds like. It's what carpenters use so that they don't have to keep recreating the wheel. And there are many, many jigs out there. We use jigs already. Metaphors, analogies, and similes are jigs, and we can map all of them. And here are some of the jigs that are out there. And what you'll notice is as we go through them, they get increasingly more sophisticated. These are all jigs. What I mean by that is these are complex molecular, not atomic. DSRP is atomic. These are molecular structures that we see over and over again across the disciplines. Molecular structures that we see over and over again across the disciplines, across different arenas, but we see them over and over and over again, P circles being one of them. So I can send you this map. This is parties and S to P jig. Feedback obviously is a jig. We see that everywhere, as SD points out so well. But these are all jigs. There are possibly thousands of jigs, many that we haven't discovered yet, but DSRP allows us to discover them. And so we've discovered, dozens of them so far. And I think there's likely hundreds more, if not thousands more. Some that are universal across all domains, and some that might occur, for example, just in physics or things like that. So learning jigs is pretty important because it allows you to not reinvent the wheel in your thinking and be able to see patterns of structure very quickly in people's thinking. And I think that's all I had for you today, other than like Q&A.
So Derek, Ed, and I'm not sure if you have audio or not, and if you want to ask this question yourself. But there's been a little bit of chat going on about resistance in university settings to even the term system science or systems thinking. And so I think Ed's asking, my question just went away because the chat got bigger, about the resistance. and in university settings, and how to make it more mainstream. And Derek, I think you're a good person to address that because you've been successful at bringing it to Cornell. So what's your thoughts?
It's funny, I have not experienced that much resistance. I think there is resistance inside of disciplines, inside of research, and in terms of like interdisciplinarity. I think that that resistance is mostly due to the lock-in of the academic structure. In other words, we hire faculty in departments. It's literally hard to find a way to pay a faculty member in an interdepartmental way. It's hard to assess their tenurability based on CVs on interdisciplinary journals, right? I mean, it's just hard. There's so much lock-in. But in terms of the way that systems have affected science, I have seen science completely shift in the last 20 years to a complexity and systems paradigm in every single discipline that I work in. And I'm welcomed into those disciplines to help them with their systems thinking. So where I would say it's much more protected is in schools. The curriculum is absolutely a third rail. Like when you try to change the curriculum of a freshman year, boy, then you're going to get into a fight. If you try to change the curriculum of K-12, that's a fight because we want control over kids' minds or whatever it is, like the people who control the curriculum, that is a fight. But in terms of science, I would say science is going gangbusters on systems in every single discipline. An example would be, systems biology or systems evaluation or systems engineering. It's just like you take systems and you attach it to a whole discipline and you alter the discipline. Human ecology, what used to be human development is now human ecology. That's just saying add systems thinking to human development and you get human ecology. So I see it totally changing all of science today.
I think it seems like there's more of an interest in the university setting, and I came across this last year. I was asked to create a systems thinking 101 course, and they already had like complex adaptive systems. They already had networking, and this was in a computer department, computer and information department. What I wanted to do is bring other people across the university in and make it cross-discipline. And then that's where I hit the barriers. Like I had an org psych person to say, oh, systems science is not my thing. And I was like, you're doing organizational psychology. I think maybe it might be your thing. And so it was just a really interesting exercise for me. To even have those conversations, and a lot of it was money. Like, how do you pay for that? How do you do that across departments? And then also the curriculum thing. Like, well, the education students can't come because their program is so set. Totally. Like they can't do another class. So it was really interesting.
Yeah, that lock-in of the logistics and the lock-in that's inside of the way, even some stuff as simple as the financial structure of the university, that really changes things and makes interdisciplinarity hard. But inside the disciplines and in terms of pushing the envelope on innovating inside the disciplines, every cutting-edge scientist I know is studying systems in order to change their discipline.
Okay. Well, we're down to 1 minute left. Ed had also given an example of Cornell's Alliance for Science is so deceptive in its outreach and narrow-mindedness, I guess. I'm not sure what that's referring to.
To the discussion we were just having?
Yep. So I'm not sure if you have any comment to that or if Ed wants to expand on that a little bit.
Ed, do you want to add to that, or? I can't possibly criticize Cornell.
No, of course not. Anyway, we'll see. Ed, let us know if there's something else. I'm not sure that Ed's audio is actually working. But Derek, thank you so much for your time. This was very informative. I think everybody got a lot out of this discussion. And Gene Bellinger had to leave early, and he just sent me an email and said, be sure that I tell you he appreciated it and he got a lot out of it, and wanted me to tell you thank you.
Great, thank you. And
yeah.
Thanks for setting this up, Deanna. These things you're doing are great for the systems community, and I really appreciate you doing it. And if anybody needs any help or feedback or anything on their mapping or DSRP use, I'm always happy to assist.
And Derek, if you'll send me the references you mentioned, and I did take notes throughout, I'll put them in the chat information, and then when I send out the link to the recording, there'll also be a link to the chat. So everything will be there.
Will do.
Okay, great. Thank you. Goodbye, everybody.
Bye, everyone.
Thanks, Deanna. Thanks, Derek.
Yeah. Bye.